Udrak Okon, are you there? Okay, I'm just going to proceed. So in last class, I discovered like a lot of people are having issues as related to like the parts where I mentioned about weight and gas calculation. So in relation to that, is there anybody like after you have gone through the materials and your own personal study, you are still having issues with that? Let me know. And if you have question as regards like the previous stuff we've covered, you can ask them now. Is there any question? No question, right? Can you guys hear me at all? Or why is the class so cold today?
Yes, we can hear you.
We
Okay.
can hear you.
All right. Emanuela, is it a question?
All right. Good evening.
Good evening.
So I just have like a confusion from the last class, and I just really want to get. I tried to look it up online, but I wasn't really sure because at the last class I got the impression that gas fees are different from transaction fees. So I just wanted to confirm: are they different or are they the same thing? I think that was the big confusion I had.
So gas fee is the same. Gas fee and gas transaction fee. Let's look at. Let me just use a class can so that you can see the major stuff there. So, what is this? So, let me just pick any transaction. So, look at it. This is the transaction fee, which is 0.66. What's the gas fee? It is 14 point this thing and GUI. And what's the current gas price? This is it. So the gas fee, the difference between gas fee and transaction fee is that transaction fee is calculated from gas fee, but transaction fee is the amount you pay equivalent in dollars. But gas fee is in terms of weight, which is the smallest unit of Ethereum. That's what you use while calculating. So that's just the major difference between them. The gas fee is in terms of like weight. If we over on it now, you can see that it's in Ether. But to get how much this number of Ether is in dollars, that's where you have transaction fee, which is $3.66. Is that clear? I think it's Emmanuel that asked that question.
Thank you.
Okay.
Yeah,
Any other
it's
question
clear.
from last? Okay. Another question? The others did not make any research as regards that. Hello? No question, Abby. From this, I'm afraid it's possible that probably since last class, a whole lot of us did not go through the research. Because if you actually went through it, I was expecting some question as regards what we've covered before and now. But it's all right. So I'm going to proceed today. So in the last class, sorry, Jesus. In the last class, so we covered on blocks, gas fee, and transaction.
Sorry, I have
So,
a question.
all right, you can ask.
Okay. Like I have a question concerning the transaction life cycle, like how it goes when actually doing transaction using Web3, how the life cycle is.
Okay. So can you mute your mic?
Okay. Sorry.
No problem. So the transaction fee life cycle, it starts from, let's say it is a transaction to send money between one account to another. It starts from the user, which is the EOA. So the user initiates the transaction. From there, after initiating the transaction, you append your private key to sign that transaction. After that, your transaction is being broadcasted on the network and it goes to the main pool. From the main pool, the miners pick it up. And from when miners pick it up, they validate your transaction and there they add it to the blockchain. That's just basically the transaction lifecycle. And to get more details, let me just give you something on that now. So let's just, I think there's a diagram on that. So here is it. This is shown. The user submits transaction submitted, pending, process confirmed. This is not well detailed enough, but I think we can go with this. Yes, you can use this. Looking at this diagram, can you guys see my screen clearly?
Yeah, yes, we can see your screen, but maybe if you could zoom in on the image a little bit more.
Okay. How about now?
Okay, yeah, I think this is better. It's
So
better.
basically, when you're building Web3 products, just like the same way you build like your normal Web2 products where you have the interface and stuff, what makes it a complete dApp is when your smart contract has a user interface. So just the same way you're able to access Google Meet now from your GUI, this is how you go about it. So basically, all these ones are as it relates to like the front end. The part where we are focused on for now is this starting from the line here. So this is this transaction that the person is submitting from this address. From this transaction, you submit it to the local node. So this is a voting contract. This is meant to like handle voting transaction on chain. So this is the one. Then number 3 is voting transaction is propagated. So Adalgo, is it based on what I'm trying to explain now? Adalgo, cool. You raised your hand. Is it based on what I'm trying to explain? Okay. So
Sorry, I don't have any question. It was a mistake.
all right. Okay, so the voting transaction is validated and propagated to the base. This base is when it's being broadcasted to the network. So from there, your transaction will now go through to the miners where they validate your transaction and before it's been added to the block. All this one is when it is being validated. This number 6 now is when your transaction has been validated. So that's just it on that. Although when we come to smart contract development as from next week, that part will be more clearer to you. Sorry, give me some minutes. I need to get phone for my PC. It's getting out. You can ask your question, the person that is down.
Okay, good evening.
Good
I
evening.
was looking up some things under authentication, and I realized that if I say, let me explain proof of work and proof of stake the way I understand it, is that in the proof of stake and consensus mechanism, miners are not necessarily the key players. Anyone, it means it from my understanding, it means that anyone that has a stake in the crypto space is now in the place to validate and verify transactions. And does this mean that the role of miners is reduced, which because of the energy consumption related to the mining and the computers involved in the nodes?
I said this in our last class that miners are only available on proof of work consensus. So when you have proof of work consensus that they are suffering for the mining difficulty, that is when you need what's it called? That is when you will need miners. On proof of stake, what you have is validators. Exactly.
Yes, but does that mean that the validator is just anybody that has a quantifiable a good word now? That's a substantial amount of crypto on the space. Does that make that person a validator?
The thing is, there are different processes before you become a validator, and it varies from each chain to another. For example, there's a major event that happened yesterday. Yesterday was 15, yeah. So yesterday that where Ethereum has successfully moved from proof of work and is now currently working on proof of stake. And there are a whole lot of things that are going to like be the new normal now in the Ethereum ecosystem. So that's just how it works. So it varies for different blockchain. So you have to like follow the requirements for you to become a validator. And you know, like you having that, for example, now on Ethereum currently, to be a validator, you need to stake 32 ETH. And this 32 ETH, you stand the risk of losing your funds if you participate in it in a fraudulent manner. So those are part of the things you should check while you are doing those stuff. Is that clear?
Yes, thank you.
All right. Okay. Any other question before I proceed with today's class? Okay. Sorry. This is what I need. So today we are going to start with Block Explorer. So Block Explorer basically are your portal to Ethereum's data. So we are using Ethereum as our case study, but whatsoever it is that I'm saying today as regards like Block Explorer applies to every other blockchain that you want to make use of. So just like we say blockchain, they are public, they are immutable and stuff. How do you get this data? How are you able to like access blockchain data? That is where Block Explorers come in. So what Block Explorer basically do is that they help you to get the real-time data on blocks, transaction, miners account, and every other on-chain activities. So like these are meant to like be the major source of truth when it comes to like blockchain, They help you like see what is going on that blockchain at the moment, and you can be able to like say, okay, this is the current gas price, this is what is happening at the moment. For example, now this is Etherscan, which is the block explorer for Ethereum. You can see currently this is the Ether price, this is the gas price, this is number of transaction, average money you should pay for a transaction. This is the last mined block. So if you look at it, this block is safe and is unlikely to be reverted. So any moment from now, this block is going to be increased. So these are different data points you will get on your Explorer. And since Ethereum is transparent by design, everything is verifiable. But how do you get this data that you want to verify? How do you know what you are verifying against? How do you go about that? That is where you need that is where your block explorer comes in. Yeah. So what are the transactions what are the data that are on block explorer? First one is execution data. So when new blocks are added to Ethereum, on Ethereum, we have the block time of 12 seconds. That is, at every intervals of 12 seconds, a new block is being added to Ethereum. So unless a block proposal misses its turn, so a near constant stream of data gets added to block explorers. Block contain a lot of important data that you may find useful. So at every point in time, each transaction, let me just ask this to ensure that we are all on the same page. What are the things contained in your block? If you pick a block on Etherscan, on any blockchain, what should be inside that block?
So good evening.
Good evening.
In a block there is a timestamp, I think. Then there's the nonce. I know you said there was the nonce, and then there are maybe the block numbers and the hash.
Okay. All right. Thank you. Matilda.
Okay, I was raising my hand because I wanted to reply. We also have the base fee per gas. We have parent hash, mix hash, the transactions, and the state roots.
Okay. All right. Thank you. So one thing you should note is, apart from like the metadata of a block, the major thing that are bundled up together in a blocks are transaction. So when you see like, for example, when we checked one block the other time in our last class, we could see the total number of transactions included in that block. So like, look at this now. This is the current block being worked on. If you look at the status, it is unfinalized. So currently there are 49 transactions there, and it has not hit the gas target. So this is the one current block that miners, since it is on proof of stake now, that validators are adding their transactions to. So that's part of the things included in this in your block explorer. So in terms of execution data now, this execution data are basically what the data that are relating to execution of a transaction. Your transaction has to be executed. When your transaction is executed, that is when it's been added to the blockchain. And so these are the different type of data that should be included in a block. There should be hash. And this hash basically is the cryptographic hash that represents the block header, which is the unique identifier of the block. The block header contains metadata about the block. And when I'm talking about metadata, I mean like metadata is basically like data associated to a particular stuff. So data associated to a block are what are included in the block header. And since blockchain basically is chain of blocks, it has to be linked together. You have to make reference to the previous block on this current block so that it can be added to the next one as the valid one. So that's why you need hash. So included in the block header also, you need the parent hash. The parent hash is the hash of the block that came before the current block. So if you look at this block now on Etherscan, you can see it's making reference to the previous one. If I want to view the previous block, I can go there and check now. And you should see that it's actually going serially, sequentially. Look at the current number. The current number is 155473332. And the number for the previous one is 155473331. The next one after this will be 1554733.
Sorry,
So
is it
that's
just
how.
me? I'm not seeing the numbers changing. Is it just
Yeah,
me? I want to, like, you are saying the numbers, but I'm not seeing them changing.
okay, I've not refreshed it, but
Okay, okay.
look at it as I hovered on this now. If you look at the bottom left of my screen,
Oh, I
where you are
see.
seeing is etherscan.io/block, you can see the number of the previous block there. Is it clear for you now?
Yes, I see.
Yeah. Okay. So that's basically how it works, because you need to make reference to this thing. So I'm going to add this now. One of the major important data structures that powers blockchain is what we call macro tree. What do you guys think is macro tree? Is this the first time we are hearing macro tree? Let me macro tree. Charlie, which one are you responding to? This your first time of hearing it? Okay. Macro tree. Ah, okay. My first time. Interesting. Can anybody explain macro tree? Yeah, let's see. What do you think is macro tree? Oh, so we have a lot of people that are hearing this for the first time, and people that are not responding to. So let me explain here. So let me use YouTube so that it will be there for everyone hearing this for the first time. So let me look for a good one. Does this guy have it? Okay, let me just look. This shit. Can you guys hear the sound?
No, not yet.
How about now?
Not yet.
No, we can't.
Local tree.
How
So
about
when it
now?
comes to blockchain, you have a
Yes.
lot of blocks, and then this blocks will talk about. Welcome back, aliens. My name is W3L, and let's continue with the series on blockchain. In this video, we'll talk about Merkle tree. Now, when it comes to blockchain, we have a lot of blocks, and then these blocks will be connected with the help of hash value. Again, how exactly that works is the thing. Every block will have transactions. Now, this can be one transaction or thousands of transactions. And then we also want to find a hash of the block, right? So what do you think? Will you just combine the entire block and find one hash? Or will you find the hash of each transaction? Now, if you want to find the hash of each transaction, you have to store all the hashes, right? So one block will not have one hash. One block will have thousands of hash. We don't want that. We want to get only one hash. One of the ways to implement that is with the help of Merkle tree. Now, first of all, we'll try to create a tree here. Now, when you look at a tree will have a root, tree will have leaves, and a tree will have nodes. So the end nodes, they are normally called as leaves. The nodes which has this leaf nodes or the nodes in between, they will be called branches, and then on the top we have root. So how do you build this tree? So let's imagine in one block we have 10 transactions. Now you will start calculating the hash of each transaction. So let's say for 10 transactions you got 10 hash value. Now what you will do, so you will find the hash value of first and second, then you will find the hash value of third and fourth, and the list goes on. So you will find the hash of all this. Now, once you got the hash of 1 and 2, you got the hash of 3 and 4, you got the hash of 5 and 6, and list goes on. Again, you will combine the hash of 1, 2, and 3, 4. Right? You will get the hash of 1, 2, 3, 4. And then at the end, you will combine everything to get a hash of 1 to 10. That's how you do it. That's how you build this tree. So in this example, you can see the end is of even number, right? You got 10 transactions. But what if you have odd number? Because normally when you talk about Merkle tree, it's actually a binary tree. So in binary tree, you have even numbers of nodes. So at the end, if you have, let's say, 9 transactions, you will at the end, you will just repeat the transaction. So you will say 9, 9 repeated. Right? That's what you do. So at the end, when you combine all these things on the top, you will get hash. That's a hash of the Merkle root. And that's how you find one hash of the entire block. Now this is very useful when it comes to blockchain. I guess once you start with blockchain, you will see how that works. So that's the basic idea about Merkle tree. So I hope you enjoyed this video. Let me know in the comment section and do subscribe for the videos. Bye.
All right. So I know that. Let me use another diagram to explain for clarity's sake.
What if I tell you you don't really need to watch this video if you know?
So Merkle tree basically allows you to like represent a complex set of data, like large chunks of data, and represent them in one environment using one stuff. So like look at this image. For you to create a Merkle tree, yes, this is a good explanation for it. Yeah, I used this when I was trying to understand the concept also. So this Merkle tree, for you to have a Merkle tree, the number of data you need to combine together must be even. So look at it, starting from here, you can see you have 1, 2, 3, 4, 5, 6, 7, 8. See, look at it like this. All the last part are the transactions. So you combine, you have hash of each of these transactions. So this second level is the hash of them. So from this second level now, you have the hash of each of the transaction on the base level. So you now hash the combination of these two transactions together to give you one hash. You combine the hash to give you one hash. So basically what this means is that what Merkle tree enables you to do is that when you have this one, this H, A, B, C, D, E, F, G, H, from that hash, you can be able to like query any transaction that is included in that stuff. So like with having one hash now, you can reference all the 8 transactions that are bundled together here. That is how Merkle tree works. That's the beautiful thing about Merkle tree. They help you index different data and aggregate it into one place. And with that single point, you can be able to like know if one data is included in it or not. Are we clear on Merkle tree now, or it's confusing? No response. Fatima.
Yeah, sorry for the background noise. So my question
No
is,
problem.
since this Merkle tree now allows us to have access to the hash of all the blocks that are included under the Merkle tree, doesn't it expose the like the security of the that like is it not going to be affecting the security of the blockchain itself, that block itself?
Okay. Do you Fatima, do you know what cryptographic hash is?
Yes, I understand that each block has its own hash, like a lengthy number.
No, don't just explain it based on block now.
Okay,
Just explain hash to me.
so hash is like it's a length of like figures that is for security reasons, like a passworded something that is specific to a particular thing.
Okay. All right. So basically, hash are being used to encrypt data. So regardless of how large the data you input to encrypt using a cryptographic hash, it will always give you a fixed size output. It can take in arbitrary number of inputs, but it will give you a fixed size output. So how this is being secured is that you are not exposing the transaction itself. And what you are doing is now, let's say we have 19 people here. I will have, so we add 1 to make it 20 so that everything is even until when we now want to create Merkle tree for the 20 people here, what you know that we are coming down to is we just need one single hash. And from that single hash that will be generated, we'll be able to know the people that are in class now or people that are not in class. If someone, let's say it is addresses now, addresses of people that are in this code that we hash together. If someone, and let's say we want to use it for something like airdrop, if someone that the address has not been included in that Merkle tree, that does not was not included to generate that hash, try to come and claim, it will fail. Because what the system will do will verify that the hash, the address that you want to like use to claim is among the things included in the hash. That way, everything is still secure. It is just a link together of the hash. And because hash are deterministic, that is why it would be possible for you to like query that a transaction was included in the Merkle tree that was generated. Is that clear now, Fatima?
Yes, thank you.
So this is what makes it possible now that what and with that now, because you know you are storing just hash, you are not taking much space. So instead of you storing each person number to a certain location, what you just do is just get the hash of everybody and store the hash. By that way, you are saving space, saving storage, and you are still doing it in a secured manner. So this is what makes it possible that you can have blocks, and from blocks inside that nested block, you can get all the transactions that are included there. I hope we are all on the same page up until this point. Or do we have any question on Merkle tree before I proceed? Okay, no problem. So the Next thing is state root. Okay, so this state root is the root arch of the Merkle tree, which stores the entire state of the system. So this state root contains all the transaction. So like, let's look at it from Etherscan now. This block also have been mined. Okay, it's finalized. So look at it now. This is the block height. This is the timestamp. This is the block reward. What I need here. So look at it, the parent hash. And this is the state root that was generated for this block. From this state root now, if you copy this thing, you should be able to, like, if you look at it now, how many transactions are included in this block? Someone should answer.
$49.
So with this state root that we have now, these 49 transactions, what you use to verify that a transaction is included in this block is this state root.
Sorry, please, how is it 49? Because me, I'm saying just two. Oh, okay,
Here
I
is
get.
the
I see it. I see it.
transactions.
Yeah, I
Okay.
see it. I see it.
So you have 49 transactions and 28 contract internal transaction. So like when it comes to smart contract next week, we are going to explain more about this internal transaction. But so any, or let's say this is just 49 transaction, and you know, like we say, you can query any data that has happened, any transaction that has happened several months, several days before now on the blockchain. So let's say you now have transaction hash. What will make you know that the block that transaction was included is this state root, which is the hash of all the transaction. It was generated through Merkle tree of all the transactions that you have here. That's what gives you this. So any transaction, because for your transaction, each transaction you have the transaction hash. So for you to claim, verify if a transaction was included in this block, what you use to check is this state root. Is that clear?
So how do we use it to check?
You said?
You said for us to verify if a particular transaction was included, we can use the state hash. So how do we use it? Is it like, are we going to write a code or something to query it?
Yeah, you can write a code, but majorly you, as if you are a user, you don't necessarily have to go through that process. Yeah. But let's say you want to like create an airdrop now for, like, let's say users that have interacted with your contract for a certain period of time. You create a Merkle tree of those hash, and then when you have the state root, the Merkle root generated, you use that one to verify anytime someone wants to claim. So you are going to, like, as you are advancing your career, you are going to make use of Merkle tree a lot. Yeah. So the next thing.
Sorry, please, before you move on. So I want to confirm that state hash is that the Mercury tree?
So the state root now
State root, sorry.
So the state root is the Merkle. When you have Merkle tree, you have something after you generate Merkle tree, it should give you something called the root hash. So the root hash basically is the final hash that you get, which holds all the data included in that Merkle tree. So this state root now is the root hash generated from that block. From that block, from all the transactions included in that block, you generate a Merkle tree from them. And so from the root hash that you get from that transaction, that is what is being represented as your state root. If you look at it here, it says the root hash of the Merkle tree, which stores the entire state of the system. When you create Merkle tree, we always come down to the root hash. The root hash is the final hash that contains everything. Is that clear?
Yes.
All right. So the next thing we'll be looking at is wallets. So basically, when you want to interact with blockchain products, you have this stuff you are working with. You have this address generated for you that stores money, store asset. So wallet basically is what helps you like manage all these things. So on a high level, a wallet basically is a software application that serves as the primary user interface to Ethereum, to any blockchain you want to interact with. So what wallet does is that they control access to users' money, managing keys and addresses, tracking the balance, and creating and signing transactions. So when you want to like create transaction, what you'll be using most of the time is your wallet. And in addition, some Ethereum wallets can also interact with contracts such as ERC20 tokens. So the wallet that you have serves as your key to interacting with blockchain products. With that, you can be able to like check your balance, transfer money to other people, interact with contracts, and check manage your private keys also. That's the work of a wallet. So more narrowly, from a programmer's perspective now, the word wallet refers to the system used to store and manage a user keys. These keys include the public key and the private key. So every wallet has a key management component. So what's an example of a wallet?
Like all those apps that we usually download.
Like,
I'm trying to remember the one I have on my phone, but this one is for Algorand. Sha. It's called Terra Algo Wallet.
okay. All right. Ose, thank you.
I would say Souffle, Trust Wallet. I think I know those two.
Okay.
MetaMask.
Okay. All right. That's cool. So those are examples of wallets, and this wallet serves as your gateway to accessing the blockchain data and performing actions on the blockchain, basically. So sorry. Oh shit. Okay. So we have two types of wallet. And at this point, I want you to know that there's difference between when you are using, we have decentralized exchanges and we have centralized exchanges. There's a huge difference between how you interact with a centralized exchange product and with a centralized exchange product and a decentralized exchange product. For a centralized exchange product, like Binance, for example, you need your password. Binance, those are like non-cost. We have custodial wallet and non-custodial wallet. The custodial wallet are the ones that you are 100% in charge of, which are like your MetaMask and stuff. You are 100% responsible for what happens there. But non-custodial wallet are those ones that are managed for you. So, for example, Binance manage those addresses for you. That's why you have. That's why what gives you access to your Binance account is password, not seed phrase, not private key. It is non-custodial. But for a custodial wallet, that is where you use your private key, your seed phrase to access them. So now moving on, we have two types of wallets. We have the non-deterministic and the deterministic wallet. So for the non-deterministic wallet, we have this thing. The difference between non-deterministic and deterministic wallet from the word deterministic. On a non-deterministic wallet, each key is independently generated from a different random number. So the keys are not related to each other. And this type of wallet is also known as JBOK wallet, that is just a bunch of keys. This type of wallet, each key does not depend on each other. When you have a non-deterministic wallet, you just have one single address and stuff. But on a deterministic wallet, all the keys are derived from a single master key known as the seed. So at this point, you need to know that there's difference between wallet and account. Your wallet manage keys, your private keys and your public keys. So on a deterministic wallet now, you can have multiple accounts created in that wallet. You can have multiple accounts created in that wallet. That's like and these accounts that you create on a deterministic wallet, they are related to each other. I'm not going to go into details of how they are being generated, but if you want to get more insight on that, go to Ethereum book and check the chapter 5 in wallet. You are going to get more insight on that. So that's it on that. So majorly on a deterministic wallet, you have seed phrase. And from your seed phrase, you can create different accounts that you can use to link each other. So an example of this is MetaMask. Let me just pop up something here. Let me show my MetaMask. So like this, my MetaMask, I have these are different network that I have here. So I have connected to a lot of networks. So let me just switch to any of the test nets. So this Rinky, for example. So and from this one now, you can see that on this wallet now, I have account 1, account 2, 3, 4, 5, 6. I have 6 accounts created with this wallet. And each of these accounts has its own private key associated with it. But for me to get this access to this wallet exactly, I need seed phrase. So seed phrase is what gives me access to the wallet. The private key and the one that give me access to the specific account that I am trying to access. So and there are a whole number of methods used to like generate wallet. You have the deterministic different structure, and most especially for HD wallet, you use BIP32 to generate them. So if you have questions, you can ask now before we go to demo. Do we all understand?
Yes.
Wow. So we all understand what I just explained. Interesting. Yeah, now let me ask questions based on that then. Jose, what's up?
Okay, you said something about the seed phrase giving access to the wallet and the private key giving access to the individual account on the wallet. Does that work for both deterministic and non-deterministic wallets?
For that works for deterministic wallet. For a yes, for a non-deterministic wallet, it is just one key, one address. You cannot create multiple accounts on a non-deterministic wallet. That is why it's called just a bunch of keys.
Okay.
Is that clear?
Yeah.
Sorry. Please come again. I missed that. Sorry.
Okay, what I said was the on deterministic wallet, that's what allows you to like create different accounts on that one wallet. But the Non-deterministic wallet, it is just one key that controls them, one key that controls the access to them. So it is basically just one no seed phrase attached to a non-deterministic wallet. It is on a deterministic wallet that you have seed phrase. That seed phrase serves as like the master key to all the other components. So for example, now let's say on your normal physical wallet now, you can have different currency in that wallet. But this different currency belongs to you, and you can decide, like, let's say it's all this kind of wallet that have compartments. Yes, it allows you to store this kind of thing. So like that, your wallet is like similar to the HD wallet where you can have multiple currency there. But the way it relates to blockchain now is that on a deterministic wallet, you have seed phrase. Seed phrase is your master key. So to now control each of the accounts. So for example, now on my MetaMask, let's say just look at it. Sorry, what's happening? Oh, okay. Let me just go to a spine view. Okay. So on like this MetaMask now. So currently, this is my public address. For each of the accounts that I have here, there are different public address. This one is 0x63, ends with 71. If I go to account 2, this is 0x3D22AB. So everything is connected to 0SAE. So everything is connected to the seed phrase. Because this MetaMask, for example, now is an HD deterministic wallet. By the time I like import this wallet now on another place using the seed phrase, I can generate all these accounts again sequentially because they are HD hierarchical deterministic wallet. So that's it. Matilda.
Okay, so I'm not too clear on this non-custodial and custodial wallet. Let me see what I know about it. So you correct me if I'm wrong. The non-custodial wallet is a kind of wallet where the user is in full control, 100% in charge. Then it works on a decentralized exchange network. While custodial is the opposite. The user is not in total control. And custodial, example of a custodial wallet is Binance.
No, that's not what I said actually.
Okay.
You know, what is the meaning of custodial? Just custodial from the word private key. A custodial wallet is when you are 100% in charge. It is in your own custody. But a non-custodial wallet, you are not the one managing that wallet.
Okay, I guess I mixed it up. Thank you.
Yeah, you get the explanation, but the difference is that, for example, now Binance account that you generate with Binance, like when you generate accounts on Binance, you are using password. You are not using private key or seed phrase.
Okay.
But you have a wallet address like 0x something something something. That is an example of a non-custodial wallet because you are not the one 100% in charge of that. Yeah.
Okay, thank you.
All right. Ose.
Okay, I think I have a Sofly account. In Sofly, I have both a seed phrase and a password. So is it a deterministic or a non-deterministic wallet?
So here is it. For my MetaMask now, I also have password. But this password is not something you can do forget password and it will reset it for you. This the software wallet that you're talking about. Basically, the password you are using is just an extra guard, but that password is not the one controlling the wallet itself. It's just to just give you some form of security in accessing it, such that if someone probably you install this on your system now and someone get access to your system, they have to use the password before they can be able to use the application. Does that
Okay.
answer your question?
Yes, yes, I understand it better.
Okay.
Hello. Sorry, I can't raise my hand. I'm using a mobile to access the class, so it
No
doesn't have
problem.
the option. Yeah. Please, something I've never really understood is how decentralized wallet right now. I understand that it's basically private organizations that mostly create those wallets for us. Something like Binance. I know the owner that is CZ Binance. You know that all of that, but then to an extent, I know that the goal for them is profit making. But then decentralized wallets, which are mostly provided by they don't have a single authority now. It's not like
Mm.
a private organization that creates. How exactly, who makes the UI of those wallets? Like how we include something like the password now. Who creates these things? Do they pay them? Is there an organization? Like, is
There's
there
a
a private
there's a
entity?
company in charge. So, for example, MetaMask is a company on its own.
Or a decentralized company, uh,
Yeah.
uh, like open source vibes?
Mm, but you have not really open source, because if it is open source, people can mess up with it. But
Yeah.
here is the thing: the company has created this product, but they are not in charge of what the user can do with the product. So they create the product. Their own is to make the product very secure, such that they themselves cannot interfere with your own activity.
Okay, I get that. But do they make profits
Well, I don't know, but
from
I
the?
expect to.
Okay.
I don't know. I don't know the model behind that. For every project, here is it. They might not be actually be make. It's a bit complicated. Let me just put it that way. I said maybe you are in the working with the company, you can tell that this is how they are generating their revenue.
Yeah, because I
But they
understand
have
the fact.
engineers, they have people working with them, and they will have to be paying those people.
Yeah,
So
yeah, that was
I
it.
I honestly don't know how it works in that company.
Okay, no problem. Thank you so much.
All right. Any other question? No one asked question, Abby. That means we all understand our class. So I'm going to.
Sorry, please, I still don't understand the deterministic and non-deterministic wallet thing.
Okay. I'm coming. Let me see if there's a YouTube video that will explain that. Let me just explain using my own words. So the difference between non-deterministic wallets and deterministic wallets is, although currently you don't have non-deterministic wallets are more of like old stuff that are no longer in use again as before. But the thing you need to know about them is that the non-deterministic wallet only allows you to like have one account per time, and each account has its own private key. So it means that for every account you want, it's a wallet. For every account you want to create using a non-deterministic wallet, it has only the ability to just take one account. But for a deterministic wallet, it can hold multiple accounts because it makes use of seed phrase. Seed phrase was not available on a non-deterministic wallet. That is why it only has private key to be associated with only one account. You cannot create multiple accounts with a non-deterministic wallet. So that's just majorly the difference you need to know about that. Is that clear?
Yes, it is.
Okay. Any other question?
Sir, sorry, with the explanation you just made, that means private organizations like Binance, KuCoin, they can't create they can't have non-deterministic wallets, right?
Your account there is not a non-deterministic wallet.
Yeah.
Yeah,
Okay.
so that's it. Because you are not, it's a non-custodial wallet for you. They are the one managing it for you. So they are the one that knows how they are managing that one. Exactly.
Yes, sir. Yes, sir. It is.
Okay. So I'm going to give you a walkthrough demo of product now. So firstly, if you want to like get used like more of the trending projects that people have built with blockchain, the first place you should come to is this DeFi Llama. Is it DeFi Llama? Actually, this is not what I want to check. But this also gives you data. Like, look at it now. These are different DeFi projects. This is MakerDAO, Lido, Aave, and stuff. You can query each of them. So, like, for example, this is MakerDAO. Yeah. So, looking at this now, so looking at this is MakerDAO, for example. You have the details of the protocol. MakerDAO, they are the people that built DAI, the stable coin used against USD. You can view the contract on Etherscan. So since we are going to come into like smart contractors from next week, just look at their contracts on Etherscan. Let's see. So here is it. This is how the security code was written for their project. So that's the most, like for example, now you don't know the code behind how Twitter works, how Google Meet works, but for a lot of these blockchain projects that are published on any of these blockchain, you can actually get to check their contract and see how they are doing their implementation. So I'm just going to show you how to use Uniswap for today, and we'll call it a day. So for example, Uniswap basically allows you to like exchange one token to the other. So if you have one token, you can exchange it for another. Let's say you have ETH, you can use it to get a Matic and stuff. So for example, now I'm currently on Uniswap. Majorly, most of the time, instead of signing, register and stuff that you'll be doing in normal Web2 app, what you'll be doing most of the time on the blockchain product is connect wallet. So this one will make your wallet to be connected to the site. So if I click on connect wallet now, I use MetaMask. All these one are different options available for you to use. So if I use MetaMask, okay, let me just connect to this one. So that's not the account I want to connect. So my account is connected here now. So basically, let's say I have this thing, ETH. Let's say this one. You can select the token you want. Let's say I want to swap DAI to mini. If I input like let's say 1, let me, since it's lower compared to each other. So let's say I input like 1,000 DAI now. If I have 1,000 DAI and I want to like swap it to get this unit token, this is the amount I will be getting in unit. So that's just basically how it. And you can see now it's showing insufficient DAI balance because on the wallet that I just connected now, I don't have DAI there. So that's how it works for Uniswap, and you can stake your assets here to create pool. You can check charts. So that is just majorly it on using Uniswap and stuff. So there are different blockchain projects that you can make use of. So they are all here. You can look at DES. So like DES are basically decentralized exchange. You have Uniswap. This one is on Ethereum. The PancakeSwap is on Binance Smart Chain. DODO is on Arbitrum, Aurora, BSC, and other 2 chains. So that's basically how it works. So that's where we'll be stopping for today and this week. So any question?
Yeah, I have a question just right now about what you just showed on. You know the wallet you have, the what's it called? The MetaMask wallet is a deterministic wallet, and you connected directly to what's it called? Uniswap. I want to know, you know how you have different accounts on your MetaMask? How exactly did what's it called? Did Uniswap have the exact account you want to use for the transaction? You get me?
Sorry, I don't get that.
I said your MetaMask account your MetaMask wallet that you just connected right now is a deterministic one where you have different accounts that you just showed us. I think about 5.
Yeah.
So I'm asking, when you connected to Uniswap, which account did you use out of the 5? How did you know the exact account you have money on for you to pick that one and connect to
So,
it?
for example, now I have this feature on MetaMask. If you can see now on this one, I name it ARC. If I switch to another one, this one account 1, there's another one I named ZKU. There's another one I named Gitcoin. So that I know the reason why I named each of these accounts that way. So I can just easily switch between them. So like you can edit each of your accounts. Let's say you come here, account. I'm sorry, where is it? So this is it. You can edit the name here. So that's how we do it.
Sorry, sir.
Is
I
that
don't
clear,
think that
Shali?
was her question.
So what's the question again?
I think she said when you connected on that Uniswap, I think it just picked one wallet. Now her question
No,
is,
I
how did
selected
Uniswap
it
know the
myself.
wallet you wanted to connect? Okay.
I selected it myself. Let me show you again. So let me disconnect. So now let's say I want to connect now MetaMask. Okay. So let me just disconnect directly from MetaMask and try the process again. Okay, one is connected. Let me switch to this account and disconnect. So now look at it. So it brings up all the option, all the account that I have here. So I can choose the one I want to pick and look at it now. The ones that there are with funds there, it's showing it. And currently I'm on Rinky BTH, which is a testnet. So you can select all. This one I select all your accounts and connect it like that. But that's not what I want. And you can pick any of the accounts that you want to connect and just go with it. So that's how you go about that. Does that answer your question?
It does. Thank you.
All right. Any other person with question? So, since there are no questions, please, as from next week, we start writing smart contracts. So please get your PC ready, get your brain ready, get everything you need ready. So, and ahead of like next class, just read up on your own about smart contracts, and we pick it up from there as from Wednesday. Yeah. Okay. No one has question again, Abby. And meanwhile, our classes are reducing. Is it because it's getting deeper? We are getting deeper. It's getting a bit complicated. Or where are others? Okay, no problem. So you guys should take care and have a lovely weekend. So we'll see you in the next class. And your assignments will be ready, will be shared across with you over the weekend. All right, bye everyone.
Bye. Thank you.
All right,
Bye.
bye.
Bye. Thank you.